Hello. So originally I wanted to bring 2 ATMs here to Buenos Aires. Airplanes don't like it when you try and bring 2 ATMs on board. So we're trying for the next best thing. So I have 2 ATMs which are going to be streaming from my apartment in California. And let's just check to make sure this is going to work.
Intentamos traer los cajeros, crean que intentamos comprarlos, intentamos mandarlos por un container. A las aduanas no les gusta que mandes cajeros, los aviones no les gustan, así que tenemos un buen link con California.
Make sure it's not jammed up there. Okay, so now I have to call my assistant back in California to make sure she can help me out here. It's hard to do an ATM hacking demo remotely, but we're going to try it out.
¿Hay alguien que trabaje acá con cajeros, industria bancaria? ¿Cómo se esconden, eh?
Come in front of the ATM and say hello. You might want to step down a little bit. Can you zoom out on the ATMs just a little bit?
Podríamos haber hecho un Skype,
okay,
¿no? Estás llamando
your face
internacional.
down. Okay, no, go back out. Okay, perfect. Okay, show your face. Show your face and wave. Please. Good enough. Okay, I will be calling you back soon. Okay, so the streaming's working.
Uno más, uno menos.
So yeah, as I was saying, the ATMs are not the easiest thing to bring around the world. So we're trying for the next best thing. Before I go into the attacks that I've developed for these ATMs, talk about some of the current attacks. And of course you have the skimmer, which is certainly the fan favorite. You know, the small overlay that slides over the card reader and over the pin pad, captures track data as it's entered, as well as capturing pin numbers and whatnot. These are no joke now. Some of them the technology is actually pretty crazy with these, where it'll capture this data, send the data over to you via SMS, text message, as well as even incorporating some tamper protection. So when they're found out, they'll send that data back quickly as well. Physical theft and RAM raids. You may have all seen some of those YouTube videos where someone will plow through the front of the store in their pickup truck, attach a chain to the pickup and the other to the ATM and belt out of there. Not really the most subtle of attacks, of course, but it can be ninja status compared to some of these others. And then we have card trapping and card snooping, typically known as the Lebanese loop, where they'll insert a small shim into the card slot. It captures the track data, or captures the card as it's entered, and they will acquire your PIN number, possibly shoulder surfing, or sometimes methods that may not be as friendly. And then safe cutting and frontal attacks, essentially just going at the ATM with a pair of pliers and a blowtorch. And then we have explosives, which I find surprisingly popular. the attack is literally tying a bunch of explosives to an ATM and blowing the crap out of it. And you would think that would be somewhat counterproductive to what you're trying to actually do there. I'm not sure how much valid cash you get from that. And this is quite big in Australia, so go figure. Sorry if there's any Australians here, by the way. And then data breaches, essentially hacking the bank processor, harvesting the card data and pins. I suppose an example of this would have been the Royal Bank of Scotland, Scotland's back end when that was hacked. I think they took about $9 million. It was certainly the most sophisticated attack that I'd seen compared to some of these others. And then I suppose we have miscellaneous other. There was the default passcode attack from a couple of years back. Essentially, they'd left the default passcodes for the operator menus of the ATMs, so you could enter in this operator password, change the denomination on the ATMs. So the ATM thinks it's giving you $5 bills when it's really giving you $20. So I'll be adding a couple more to the other category, which in my opinion kind of blow John Connor's attack right out of the water. So I've picked standalone retail style ATMs, and there's a few reasons. At least in the US, they're fairly easy to get a hold of. I hear that's not the case in Argentina, Federico. Literally on the internet, I can jump online and add to cart and have these ATMs delivered to my house. And getting the ATMs delivered to your house, on the other hand, is quite interesting. The guy, he literally wheeled in the ATM into my place, and not surprisingly asked, why on earth do you need an ATM in your house? And me feeling a little bit cheeky that day, I just said, just don't like the transaction fees, mate. He kind of shook his head and went on his way. And also, they're everywhere, so every bar, convenience store, market. They're also often in secluded areas, you know, out by the restroom, so they're tucked away in corners. But I will discuss attack methods for both standalone ATMs as well as hole-in-the-wall banking-style model ATMs. So I'm going to talk about walk-up style attacks, but then I'm going to shift to, in my opinion, which is the far more important vector, and that's a remote attack. And when I talk remote, I mean like remote default attacks, because that's the only way to roll, really. Just as an example of a couple of these ATMs, this is about a half-block radius from my house. So I just went and figured I'd grab a couple of pics with a few of them. Bit of a pub crawl. This guy here owns the Mexican restaurant down the road. Notice he's got the bottle of Tapatio over the top of the ATM. Doesn't look too excited to be in the photo though. So standard specs of a new model retail style ATM. It's Windows CE, typically running an ARM-based processor, so ARM or X-Scale. New models support both TCP/IP and dial-up by default, and optional wireless, but when I say wireless, I'm talking CDMA, not 802.11, so unfortunately no drive-by ATM looting attacks, unfortunately. And SSL support, as well as a triple-DES encrypted pin pad. The pin pad performs all the encryption within the device itself, has anti-tampering mechanisms and so on, and if time permits, I'll talk a little about some of the tricks we came up to get around that too. So this is the typical ATM internals of one of the ATMs I have there. And the only thing that differs from this compared to the ATM I have is I've just removed the faceplate. And I've only done that for just photo purposes. I guarantee the two ATMs I have at my house, completely untouched, completely unmodified. So the attacks will be on exactly how it would be on the first ATM installation. So you have various inputs there, the motherboard inputs, multiple USB, SD cards, network, and a few debugging ports. And funnily enough, actually, of all the possible ways an ATM talk could be disrupted, and I originally did this in Las Vegas, it was my cat who almost ruined it for me. I had a USB keyboard plugged in, he was chasing a moth or something, tripped over it, pulled out the processor motherboard, and luckily I could have just soldered back in the USB, but anyway, bad kitty. So in this presentation, it's not going to be a full-blown technical tutorial. So I'm going to be following up with a white paper. Of course, if you want to know the ins and outs of creating CE kernel rootkits and some of the more technical aspects, I'm more than happy to have a chat at the bar or whatever it may be. But I just thought I'd sum up the security hurdles that I faced with this quote. And this quote comes from a book called Inside Windows CE, which was interviews with the core developers of CE. And from Thomas Fenwick, the CE kernel creator, this quote was, "We were concerned about protection, but not about security. We weren't trying to design an airtight system like Windows NT." So, so there were not a lot of roadblocks, I will say that. So before we can even think about actually devising some ATM attacks, we need to actually gain access to the ATM file system itself. And then with access to the file system, of course, we can transfer the executables to be able to reverse engineer. Now, when the ATM boots, it boots directly to a proprietary ATM application. So there's no Explorer shell or anything like that. So of course, just to make things a bit easier on us to actually do the vulnerability research, we need to actually force Explorer.exe into the boot list at boot time. So the CE application boot sequence is fairly straightforward. The kernel NKExe runs filesys, which initializes both the registry and the file system, and then executes the applications listed in the registry key HKLM init. So the trick is to patch the application we want, execute it into that boot list. So of course, to get Explorer into the boot list, there's a couple of approaches. The first approach assumes you actually have a copy of the CE ATM image. The registry file can then be extracted, modified, and then recompiled into the image. This of course requires a way to rewrite the flash memory, whether that be Ethernet, serial, JTAG, or what have you. And the other approach is just to patch Explorer.exe as it's booting directly, which requires of course some other debugging capability, whether that be JTAG or serial, whatever. So I decided to take the JTAG approach, just simply because it's a fairly straightforward way to accomplish our goals. JTAG, if you're not sure, is a hardware debugging interface, which essentially gives you unrestricted debugging access to the processor core. And the hardware used to be fairly pricey, but these days with some of the open source initiatives like OpenOCD, you can get all the needed hardware for less than $100. So it allows both kernel and bootloader debugging. I can remotely debug with GDB, debug the kernel, the bootloader, and JTAG's been talked about to death, so I won't dwell on it, but there's a lot of resources online. So here's just a quick snap of a hardware debugger connected into the ATM. It probably seems obvious, but the use of hardware debuggers and things of that nature have absolutely nothing to do with the attacks that I'm going to be demonstrating. They're really only used just to be able to gain initial access to the ATMs to get the files. And speaking of JTAG, I learned a valuable lesson. I had the JTAG plugged in, I was messing about with one of the ATMs, and I accidentally overwrote the entire ATM firmware and all its executables. And at the time I was not able to get the ATM software because I wasn't a licensed ATM technician. So I had to call a licensed ATM technician, and they came around to my house, and again, 3 guys walk in and like, "Why do you have ATMs in your house?" And so I'm like, "Oh, I haven't moved them into the store yet," and all this type of thing. But anyway, he's like, how did you wipe out this firmware on the device? And I said, I was trying to change the splash screen, you know, on the SD card, and it just killed everything. And he's like, "Oh yeah, they'll do that. So then he pops open the ATM, he taught me all these ATM hacking tricks, so I admire him for that. I got his business card, we kept in touch, but I think after first giving this presentation, that relationship may be severed. But so the lesson is always back up your firmware. So of course, now that we can debug, we can inject. And with the debugger connected, we simply set a breakpoint on create process when it's in the filesys address space. And of course, with the ARM architecture, parameters are passed in registers before they utilize the stack. So the application name will be passed in register 0. We just override that with Explorer, and it will basically execute into that boot list. So explorer.exe has to exist on the C image for this to work. If it didn't exist, you can always copy it to a removable drive and just give the full path name. So then you get a shell on the ATM, and now we can actually copy those files off and begin some proper reverse engineering. And when I first had the shell on the ATM, I was quite excited and had movies playing on it, and it's actually quite crap for playing movies, by the way. It's like a six frame rate, so like 6 frames per second or something, so it's not going to replace the TV. So with the shell, we can now plug in the USB drive, keyboard, copy off the files. Then we can just modify the registry, so when we're playing with this ATM, we can now always have it boot to Explorer, which just helps matters for debugging. Because remote debugging with JTAG over GDB is obviously not the ideal way to debug a Windows device. So there's an easy way to debug Windows CE applications without having to use ActiveSync, and that's to debug with Visual Studio over Ethernet. So you can simply build an empty project, overwrite the local executable with the executable you want to debug from the ATM, set up your TCP settings, copy the file over to the ATM, and now you have remote debugging with Visual Studio. So now we have everything in place to actually not only create some attacks, but also test them on the ATM. Okay, so finally, with that out of the way, we can talk about planning an attack. So there's a fairly limited attack surface, of course. You have the card reader. Now, assuming we had like an overflow or something via one of the card tracks, not only is there an extremely limited amount of characters, but extremely limited character set. So I'm not saying it's impossible, but I would say it would be unlikely to be a practical or reliable attack. And then we have the keypad, maybe a long shot, but maybe there are backdoors or secret passwords left in by the developers. And then of course the network, so any open ports, answering phone line, any options for some remote attacks. And then the various inputs on the motherboard itself, but of course this requires access to the motherboards. So of course, you always have a few failed attempts along the way. And in my attempt to kind of recreate a Terminator 2 style hack, I made this device, which is it's basically a media player hooked up to an electromagnet, media player hooked up to an amp, which is hooked up to an electromagnet, and you can create WAV files that simulate the magstripe data, put it in your ATM, flick the switch, the ATM will think it's really a magstripe card. I was trying to find overflows, but I think actually if you walked up to an ATM with all this stuff, you have a pretty high chance of getting caught there. And technically it works great, but it didn't help me at all for finding vulnerabilities. So I'll talk about the walk-up attack. Of course, we need to load code on the ATM. Now the cash dispenser is housed at the very least by a safe, and if you take a more expensive option, you can have like a full-blown vault, basically. The motherboard, on the other hand, is protected by a one-key-fits-all lock. And this is standard practice with all of the ATM manufacturers, Diebold included, although I couldn't find a key to show an image. You can often find them on eBay. So, of course, with like anything else on the internet, these keys are easily bought, easily added to cart, and easily shipped to wherever you want them to be shipped to. So now with your master key, you can have access to the USB and the SD card slots on the ATM. And you can pop open the motherboard compartment, insert a USB key within a couple of seconds. It's a lot faster than installing a skimmer, for instance. Now, even though the attack time, of course, would be short, there's always that possibility of detection. But I think the way even psychology comes into play, you consider it kind of rude to look over the shoulder of someone using an ATM. But I suppose if he was looking over your shoulder while you're doing this, he may learn a trick or two. Now, all ATMs need ways to upgrade their firmware. And this is most often leveraged via the removable drives. So the ATM application will check the drive for a valid firmware upgrade, finds that valid upgrade, will install whatever we decide to add in there. Now, of course, the format is typically a proprietary format, with the executables encapsulated within the firmware. There's checksums, encryption, and but these algorithms are easily figured out by reverse engineering the code on the ATM side. And once you create your own firmware package that adheres to the correct format, you can upgrade, but of course with a few modifications. Sorry, I was feeling a bit parched there for a second. So now the remote attack. Now I would actually say all ATMs that are running some form of Windows-based operating system support some form of remote monitoring and remote configuration. This allows you to log into your ATM remotely. You can retrieve and change the settings of the ATM, change the splash screens, and so on. Now another useful feature is the ability to remotely upgrade the software on the ATM. Now this is sometimes a feature, but it's always something you could leverage via some sort of remote vulnerability. Now, of course, authentication is required to be able to do anything useful. Now, with the particular model I'm going to demonstrate on, it required both a serial number and a password. And they're both made up of a combination of numbers and letters, forces a 5-second delay after every connection attempt. So, a brute force is somewhat out of the question. So, of course, we require a vulnerability within the authentication process itself, and it just so happens. So, introducing a tool I wrote called Dillinger. And Dillinger is my, Dillinger named after the bank robber, of course. But Dillinger is my remote ATM attack or administration tool, however you want to look at it. The core of Dillinger is the authentication bypass, which is the remote vulnerability in the specific ATM. So Dillinger, of course, takes advantage of that vulnerability. Interestingly, although most operators of these ATMs don't utilize this remote functionality, it is enabled by default on all of these ATMs as they ship out. So, cha-ching. So typically to log into the machine, as I said, you require knowledge of both the serial number and the password, but due to this vulnerability, I can bypass all authentication on the device. And I'm going to say the remote attack is 100% reliable, but every time you say that, especially when you try and hack an ATM in California from Argentina, it may be the real test of the demo gods, but we will see. So Dillinger supports both TCP/IP and dial-up. And I heard from a fairly knowledgeable source that most of these retail-style ATMs, a good 95% of them are still operating on dial-up. Now, of course, back in the day, to find these machines out in the wild would require nights and nights of war dialing. But thanks to tools like HDMOR's Warbox, which utilizes VoIP, you can essentially scan out an entire 10,000 number exchange in a matter of hours. So you can then find all the modems on that exchange, write a custom war dialer which looks specifically for these ATMs, and you're away. So some of the features of Dillinger, its interface will allow management of an unlimited amount of ATMs. So you could add a group, say a city. Under that group, you would add each individual ATM and either its IP address or its phone number. Now the heart of the tool, as I said, of course, is the authentication bypass. And that's a stepping stone to doing anything useful, really. So one feature in Dillinger is to be able to test the bypass remotely, but not actually leave any trace on the ATM itself. So the obvious problem with finding a remote ATM is you have no idea of the location. So Dillinger can also pull the ATM settings remotely, and when you use an ATM, you see at the bottom of the receipt it always has either the name of the business or the name of the location. Also, the possibility to upload a rootkit that I've designed specifically for these ATMs. Again, it bypasses authentication, initiates a software upload, and will let me replace the firmware remotely, so that's pretty awesome. So in general, someone's going to need to be at the ATM for any of the, or to get the payout, I suppose. So I've added another feature so it's possible to carry out a remote attack without ever having to visit the ATM. And I basically capture everyone's track data as they enter their cards on the ATM. This track data is saved on the ATM, but then can be pulled remotely, so you could essentially create your own cards, never have to visit the ATM. And the remote jackpot, but I think that one will speak for itself. So now introducing Scrooge, which is the, I like silly names, by the way. Scrooge is the rootkit that I developed specifically for these ATMs that are for running on CE. Implements the typical rootkit technologies that you expect from a rootkit, so it hides itself and its friends by hooking various Windows CE syscalls. hide the stuff from the process list, hide the stuff from the file system, and so on. Now there's a hidden pop-up menu which can be activated either by a special key sequence on the ATM or by inserting a custom card with custom track data. So it'll run on any ARM or H-scale based ATM, it'll run on Intel with a few tweaks, but it turns out there's not many ATMs that are Intel based that run CDs, so I decided not to add that functionality. The code, of course, has to be, for interfacing with the ATMs, has to be customized for different ATMs, as they will use like different peripherals and non-standard ways of communicating. But this specific rootkit was designed for two major models of Windows CE ATMs. And then in the United States, they claim 460,000 ATMs in North America. One of these retail manufacturers claims sales of 130,000 a year. So it's a fairly big chunk. And the other one is another major vendor as well. So with the Scrooge hidden menu, it's essentially just a standard set Windows hook keyboard filter that captures the side buttons of the ATM. Now, although that set Windows hook is actually undocumented on CE, it still exists and works as you'd expect. So a combination of keys will trigger the menu, and it's very varied enough not to be launched by accident, I suppose, but maybe a kid playing around would have an interesting time. So the card reader is hooked via an inline detour style patch, essentially where you patch in a branch instruction to a piece of code that you'd like to intercept. The branching jumps to your code executes, returns to your original function. So with the hook, I put a hook on the read buffer, so every time it reads a card, and if the track data of track 2 matches gimme dalu, that will pop up the menu and allow some of these menu functions. So the menu functions will allow you to dispense from each of the 4 cassettes in the ATM itself, print stats on the remaining bill counts, or just exit. So to add my own functionality, I've added in a few inline patches. As I was saying, there's detour style hooks. So of course this could be done dynamically, but the fact that these vulnerabilities allow me to actually replace the executables entirely on the ATM, I can actually just make these permanent changes. So it's a lot easier, and of course with ARM, with all instructions being 32 bits long, it's fairly easy to implement. So I place hooks at the card reader, the pin pads, and the parser that handles remote configuration commands. So now I can add in my own remote configuration commands. Of course it doesn't do what the ATM would expect, remotely jackpot, pull track data, that type of thing. I will quickly skip over the pin logging. Just if I have time, I'll go back to it. But I know this demo is going to be quite trying, so I'm going to see if I can get this working first. Okay, so this is Dillinger's interface, and okay, hold on, I need to find the IP address. Okay, so I can now add a group. So I'll make the group name San Jose, California. Now add an ATM, Barnaby's ATM. My house. And I have this one, of course, connected on the internet at the moment, but Dillinger, of course, as I said, supports both dial-up and TCP/IP. So you can, either will work fine. Let's go to the IP address. And the remote port for looking into these ATMs is 18456, but I found it quite interesting when I was looking through the manual that this port can't actually be changed. Okay, so let's see if we can. So this is the this one on the right is the ATM that I'm going to be performing the remote exploit on. So I should be able to first test the bypass. Okay, so attempts, connects, testing bypass, success. So, okay, you can probably see, we'll load this up. All that is shown on the ATM is RMS process. So it's not something that's going to be too noticeable. So now I've essentially just checked for the vulnerability that it exists, but it's not going to modify anything specifically on the ATM. And that should go away in just a sec. It's probably like about a 5-second delay. Okay, so now that we know it works, let's upload the rootkit to the ATM remotely. And I'll upload the final version of Scrooge. I know I'm connected on the network. I figured it would be best not to be on the Wi-Fi for doing this. Whoops. Okay, connects, sends bypass success, sends a software upload initiation, success, and now it's uploading my rootkit firmware remotely to the ATM. Now it takes a little while over the network, because even though it is over the network, they've implemented their own proprietary protocol which acknowledges every packet that comes in. Of course, it has its own proprietary encryption, and you all know what happens when you implement proprietary encryption. Okay, so this should probably take a couple of minutes, so if anyone has any questions in the meantime while this is happening, feel free.
Barnaby, have you seen the ATMs in Argentina?
So I had a bit of a peek here. Now every time I go to an ATM now, I look at them differently than I used to. But so I noticed that over here it seems the NCR has a bit of a stronghold. And the difference with the banking style models and the retail models, the banking style models, they do support forms of remote management, but the actual banking style models are typically just a Windows XP or Windows 2000 box enclosed. So even though they're harder to actually acquire, I'd imagine they would actually be easier to compromise. But no, I haven't looked too closely at them.
¿Alguien tiene una pregunta mientras le va cambiando el firmware al cajero? O fíjate. I just said, like, if anyone has a question while you're rewriting the firmware. Where? Whoa.
Okay, so now the firmware has successfully uploaded, so we can go back to the ATM here. And now I'm going to call in my assistant. Okay, so the girl who's helping me is not technical in the least, so if she can hack an ATM, anyone can hack an ATM. Okay, so yeah, once the rootkit is uploaded, the ATM will reboot, and now the rootkit should be running in the background on my ATM. Yeah, it may have been tampered with. So interesting, actually, when I first gave this demonstration, we tried everything to hide up the logos, but I actually forgot that, of course, it shows the logo as it's booting up on the ATM. Hello. So you have your first test, and that is to enter the special key sequence, and then dispense 50 bills from cassette A. Okay, right now. So when she brings up this hidden menu, the 4 side buttons will allow her to dump from the 4 different cassettes in the dispenser. Okay, so these are the key sequences. Okay, so that's the hidden menu. Now let's see if it starts dispensing some money there. There we go. Okay, so you can press the exit button now. And then I need you to enter a credit card. Yeah. Okay, yeah, so grab a credit card. By the way, this credit card she's using, I have changed the numbers on it, so... no, so you don't need to enter a PIN, just press cancel now. Okay, and I think that is all I'm going to need from you until we show the walk-up style attack. Okay, so I will be calling you back. Okay, so now she just entered in a credit card, didn't need to enter the PIN, but now I hopefully should be able to now pull that track data which I would have captured. So let's try that. Again, attempts connection, retrieving stripe card data, save to disk. Okay, so this is track data of a few different times that we've been using it. You can see the Gimme Dilute, which was my special card, and of course the track data here of Andrea Hearts, but things have been changed to protect the innocent.
So that would be like a keylogger for ATM, right? Kind of.
Say again?
That would be like a keylogger for an ATM.
Exactly. Okay, so as I was saying, so you find these ATMs in the wild, you have no idea of the actual location. So let's pull the ATM settings. Okay, and save to disk. Okay, up here you can see the master passwords to my ATM. Barnaby's, this is my receipt data, Barnaby's ATM. I don't actually live at 123 Kiwi Street though, but I am in the San Jose area. As well as that, it has the phone numbers, the IP addresses, and so on. So now, of course, you know where the ATM would be if you're going to go and implement an attack. Now, finally, for the remote attacks, let's just try the remote jackpot. Let's see if I can get a big screen here. We have a winner. Okay, so now it's just remotely dumping cash from that ATM. Now I will have her demonstrate the walk-up attack, which if you remember was simply using the master key, which are easily available, which open all models of this ATM. I've just opened the faceplate down the bottom, but I haven't opened the safe or anything. I think it just makes it look a little better if the demo starts to work out. So I'll have her basically perform that attack. So she's just going to quickly unlock the ATM, insert the USB key, and reset the ATM. Now this will be interesting. I wonder if there's some way I could get the sound coming from there. I think my mic is not working there, but maybe we could. Babe, do you want to do the? Can you perform the walk-up attack? But can you put your phone on speaker? But I don't have the mic connected at that end. So you remember the attack? Okay. Yeah, go. This is making me nervous. All right, well done. No, you don't need to open it again. Okay, here you go. Very well, very good. Now, if you just want to put your phone on speaker somewhere near the ATM, and I'll see if we can get some sound coming through. So maybe I can put this one on speaker too. Hopefully the ATM is actually plugged in. Okay. So now as it's booting, it'll be reading the firmware off that USB, and I've designed something specifically for Ekoparty. It's not, okay, it's a little hard to see, but so I wish we had slightly better resolution with the streaming, but it's the Ekoparty logo is going to float around the screen. While it's doing this, it's initializing the dispenser and everything else. Usually takes about a minute and a half or so. You got it on speaker? Yep. Okay. So I can figure out how to put that one on speaker.
Try to talk. Hello?
Hello?
Keep your phone on.
It's on.
It's saying Jackpotting. Yeah, can you just show the floor really quickly? No, show the floor, show the floor. What? No. I mean, show the floor of the apartment. I'm not sure what you're doing to my ATM right now. Oh, okay. But anyway, just show down, just pan down and, okay, well done, you did well. Okay. Back to the presentation. Oh. Okay, so countermeasures. The obvious physical countermeasures would be to offer upgrade options on the physical locks. But at the same token, if you have a fleet of 2,000 ATMs, you're not going to want to have a different key for every single ATM you have out there. So the approach that, for the walk-up attack, the fix that they implemented was to actually implement executable signing at the kernel level. So now all executables allowed to run on the ATM have to be digitally signed. Now, if a trusted environment was set up, which essentially only allows signed executables to run, that would have prevented the original attack, although it wouldn't have prevented the actual attack vector of the remote attack, it would have added somewhat of a barrier. Now, unfortunately, in implementing that in Windows CE 5 is not a straightforward task, which I think it should be. You have to add additional code to the build and so on. But what you can actually do to prevent that, prevent the remote attack, is to just disable remote management on the device itself. Most of the people aren't going to be using it, and I find it interesting that remote management on these devices were specifically enabled by default to allow the manufacturer to issue security updates to the ATMs, which is, I find a little bit ironic. And finally, I think it's just time to give these devices a bit of a rehaul. There hasn't really been secure development methodology in place from the get-go, so there's a need to play catch-up, have the code audited, have penetration tests, and implement these best practices from here on out. And I think there's been somewhat of a noticeable surge in the community to sort of researching these proprietary devices that we all rely on, like devices that when compromised have sort of direct and immediate consequences, ATMs being an example, medical devices, you know, the computer system in your vehicle. So I think it's important that we dig in, research these devices, locate the vulnerabilities, get this stuff fixed, and ensure kind of a more secure future, I suppose. So, thank you.
¿Alguna pregunta? Pregunta.
Let's see if that
Hola.
ATM is still spitting out money.
I have a
Yes.
question. You're some kind of hero to me now, because you can do what you want with an ATM and with a beautiful blonde woman. But I have a question. Don't you think that the remote management services are by default enabled because they trust in the security environment of content, that they can control the environment from the network they are connected, the ATMs. So they allow to remote management the ATM because they trust in the security.
Right, and sorry, I think I see where you're coming from. And they essentially trust the people connecting to that remote network, and they've implemented authentication. And I suppose the remote management, it's not a vulnerability that's going to be one shot that works across the board. The remote management is that attack surface that leads to all these possible vulnerabilities. So I'm just trying to think how to best answer the question, but.
If you do an attack in the network to an ATM, you can have the CIA, DA, everything in your home in 5 minutes. That's what I mean. They trust in the security over the network.
Oh, right. Okay, so, and I think that's what was an important point about these retail ATMs, is that most of them just aren't network connected, so they're not behind any perimeter firewall or anything like that. They're just straight available to connect to over the phone line. So there's essentially no protection there for these style of ATMs. But when you start talking about the banking models, typically it will be on an internal network. So you'd have to compromise that network first. But on the other hand, if you compromise a standalone ATM via a similar attack, you are now on that internal ATM network.
¿Alguna tiene otra pregunta? Ahí tengo. Le paso por allá.
Are you going to hang out delinking USB devices to the audience?
Sorry, it's just the battery. I just never use it.
¿Alguna pregunta?
Te quería preguntar, después de que instalaste el Rootkit, cuesta capturar el track 1 y el track 2 de la tarjeta. Y en alguna parte de la presentación, after you install the Rootkit, you got the track 1 and track 2 from the card.
Right.
And in part of the presentation, you mentioned that you can attack the pin pad.
Okay, so yeah.
So I wonder, as far as I know, I understand that the pin pad protect the pin and with the master key in the ATM. So I wonder how you can attack that.
So the encrypted pin pads also have to they have to double as general input devices. So when the encrypted pin pad isn't on, that is basically just a general input device for us, saying how much cash you actually want to spend and all that type of thing. So of course you can turn the encrypted pin pad off. So the attack I devised, I essentially turned off the encrypted pin pad. I popped up a fake screen that says enter your pin. They enter the pin, that pin's captured. I turned back on the encrypted pin pad, and I made this fairly random so it would happen, it wouldn't be too noticeable. But attacking the actual encrypted pin pad itself is something I haven't looked at. I figured there was an easy enough way to bypass it without having to sort of dig too deep.
After you found this vulnerability or this exploit, what did you do next? Did you contact the sellers, or what happened in your mind?
Right. So
Were you at the pub? Did you buy a round for the guys?
Yeah, so I had a few conflicts of interest, I suppose, and but I don't think my mum would like it if I was in jail, so I thought about that. But basically, so we contacted the manufacturers, and I was actually originally meant to give this presentation last year at Black Hat, and crazily enough, the ATM manufacturers weren't big on that idea, so they essentially asked Juniper somewhat nicely to please cancel the presentation that year. At the time, they didn't have the fixes they had the fixes in place, but they didn't have enough time where they would be able to distribute it to everyone. But now, once I finally got to give the presentation, and now I had another ATM as well, of course, they worked with us to implement the fixes, and they've taken actually a fairly proactive stance on security now. They contacted everyone, they're issuing fixes now. I'm probably going to be doing a bit of work with them personally as well. But I didn't go rob ATMs. That's the short answer.
Any question?
In a lab environment. No further comments.
Barnaby, when you phone the ATM, why does the ATM have to pick up the phone?
Why does it have to pick up the phone?
Why does it pick up the phone? I mean, it should dial out. It should never allow someone to dial into it.
Well, I mean, yeah, it dials out to connect to the bank processor, but that's why they have this remote management, so you can dial in to actually manage your ATMs remotely. That's literally the only reason it allows that.
No, but it's do dial back. It always do dial back. You ping it, and then shouldn't it always just do dial back? So, you ping it, and then it dials a number that is hard-coded in there back. And that's how you do it.
That would probably be the correct way to implement something, yes. All right, thanks a lot.